So, now we will take polygon law of vector addition. Here we have to take number of vectors. Till now we were taking only 2 vectors. Now here we will be taking number of vectors. Suppose you have taken vector A like this, and this is vector B, and this is vector C, this is vector D. So, I have taken 3 vectors. All these vectors are in the same order, like vector A, vector B, vector C, vector D. So, if you take these two are representing triangle. So, we can write like this is this vector, that will be here vector A plus vector B. Now, if you take this vector, this A plus B and C, they are again according to triangle law of vector addition, we can write like this, and that will be here A plus B plus C. Now, the last vector which we draw from here and taken in opposite order and which is actually closing the polygon. So, this one is known as R, and this R will be here vector A plus, vector B plus, vector C plus, vector D. So, see here we have taken more than 2 vectors, number of vectors, they are taken in the same order representing the different sides of the polygon. Then the closing side is representing resultant of all these vectors. So, this is the polygon law of vector addition. Now, we have to come to the analytical method of this vector addition. So, now in analytical method, that means we have to find out the magnitude of the resultant vector. So, analytical treatment of triangle law of vector addition. Basically, we are going to find out resultant of 2 vectors. So, now suppose you have taken 2 vectors like this is vector A, we can write it as here O and P. Another vector I have taken as here, this is vector B, this I have taken as Q. Third vector which is drawn here, that is here R, closing side. Suppose this angle is theta, these 2 vectors are acting at an angle theta. So, now just we draw a perpendicular from here, and this perpendicular we can take T. So, QT is perpendicular to OP produced here. Now, see in this one OTQ is a right angle triangle. So, we have to calculate the value of OQ, but by using, if you take triangle here, in triangle PTQ, you can write cos theta is equal to PT upon PQ. So, PT is equal to PQ cos theta, that will be here B cos theta. So, value of PT we have got B cos theta. So, this one we can write here B cos theta. Similarly, we can get by using sin theta, this will be here B sin theta. Just in this triangle you take sin theta, you will be getting the value of QT, that is B sin theta. Now, we can get the magnitude of R, we can get this length OQ. So, how? Just we write here OQ square is equal to OT square plus QT square. So, we can write here A plus B cos theta square plus B sin theta square whole square, and this OQ can be written here R square. We can break this bracket. So, we will be getting r square is equal to a square plus b square cos square theta plus twice of ab cos theta plus b square sin square theta. Now, b square sin square theta, b square cos square theta. You know sin square theta plus cos square theta is equal to 1. So, we can write here r square is equal to a square plus b square plus 2ab cos theta. So, r can be written under root of a square plus b square plus 2ab cos theta. So, this is the magnitude of this vector r. See here, magnitude depends on angle theta. It means r can be changed by changing the angle between vector a and vector b. So, now after getting this resultant, we have to also calculate direction of the resultant vector, that means this one, how much this is making angle with the vector a. So, now we will do rest part of this in the next slide. So, as we have done the calculated magnitude of the r, and this was r is equal to under root of a square plus b square plus 2ab cos theta. We have just calculated this in the previous slide. Now, we have to calculate this. You have got the magnitude. So, now you have to see at what angle this resultant vector is acting. So, we can get this also, tan beta is equal to, see the triangle, it is a QT divided by OT, QT divided by OT, that will be here b sin theta divided by a plus b cos theta. So, from here b sin theta divided by a plus b cos theta, by putting all these values you can get the value of beta, but here you will have to take the help of the trigonometric table. So, by this formula you can calculate angle between r and vector a. Now, see the different cases. Now, I will be using this main formula resultant of the two vectors. In this case, you know it, I am writing again this formula, r is equal to a square plus b square plus 2ab cos theta. First point I am taking, if theta is equal to 0, what does it mean? Two vectors acting in the same direction. Maybe they may be like this, or they may be in this way also, a and b. So, when the two vectors acting in the same direction, it means between the angle between them is 0. So, just look at this one. What will be here? R is equal to under root of a square plus b square plus 2ab, because cos 0 is 1. So, r is equal to, you can write under root of a plus b whole square, that r is equal to a plus b. You are getting maximum magnitude. So, when the two vectors act at an angle 0 degree, their resultant is maximum. Now, you can see also the angle between them, like you have seen here tan beta, it was here b sin theta upon a plus b cos theta. So, now see here b sin 0, because theta was 0 here, divided by a plus b cos 0. So, now this is 0 divided by this, that everything has to be 0. That means you will be getting beta is equal to 0 degree. Now, you have taken theta equal to 0. Now, I will take theta is equal to 180 degree. So, second point, if you are taking theta is equal to 180 degree, cos 180 is equal to minus 1. So, you can write r is equal to under root of a square plus b square minus 2ab, that will be here r is equal to a minus b whole square and under root. So, r is equal to a minus b, that is a minimum. So, you can get the value of r according to the theta, that is if theta is equal to 180 degree. Similarly, you can take next point when the theta is equal to 90 degree. So, if you are taking theta is equal to 90 degree, what will happen? Cos 90 is 0. So, r is equal to under root of a square plus b square. This is the resultant here, and in this case also you can see here tan beta is equal to b sin theta upon a plus b cos theta. So, that you can write here sin 90 is, that is b upon a only. So, beta is equal to tan inverse 1 b upon a. So, angle can be calculated. So, this is about the resultant of the two vectors by using triangle law of vector addition, but same method you can follow for the parallelogram law of vector addition. So, magnitude and everything is just can be calculated according to triangle law of vector addition. For the parallelogram also same concept are applicable for parallelogram law of vector addition. So, now we will do analytical treatment for the parallelogram law of vector addition. So, see here for the magnitude of r, you can say in case of the parallelogram law of vector addition, if you have taken two vectors like vector a over here and vector b over here, these two are representing adjacent sides of a parallelogram, angle between them is theta, this point is O. Now, you have to get magnitude. We draw parallel to this vector over here, this is vector A, and here parallel to this is vector B. Now, we join this is a diagonal and this diagonal is representing resultant vector. So, we can take this is P and this is Q. Now, what we do here, this is vector B here, this angle is also theta. So, just we draw a perpendicular from Q, that is here T, and by the same method as we did in the for the triangle of vector addition, this will be here B sin theta and this will be here B cos theta, and by using this previous concept we can get, because this is acting as a triangle law. So, we can get r is equal to under root of a square plus b square plus 2ab cos theta. And if you are taking this angle beta, that means the resultant making angle beta. So, that you can get tan beta is equal to b sin theta upon a plus b cos theta. So, every method is same. This analytical treatment is same for the both triangle law of vector addition as well as parallelogram law of vector addition, because this is also acting as a triangle here. Now, after this we can take certain rules like vector law of vector addition is commutative. It means if you write vector A plus vector B is equal to, that will be vector B plus vector A. So, that means the vector addition is commutative. It follows commutative property. Also, it follows associative property like this: A plus vector B plus C is equal to vector A plus vector B plus vector C. So, vector addition is commutative as well as associative.